This is the effect that creates mirages, is it not?
It could, depending on the nature of the temperature gradient, you could have mirages that come with the sinking refraction, but you can just have the sinking refraction as he's describing here disappear and be cut off the bottom, like,
Yes.
and drop down.
Yeah. So I think it's pretty connected there. So in any
What?
case, the solution would be to do a better experiment. And I mean, I think there are
What
videos of
does the
this
better
already done. I think
experiment
people have done it.
entail, and how do you differentiate between curvature and refraction?
I think you need to compute the effects. Like I said, use the worst case scenario for a
How do you do
temperature
that?
for a temperature inversion.
How would you personally be able to differentiate that it's either curvature or refraction? How
I
do you
told him the
determine
answer
that?
earlier.
Because
Yeah.
you
Let's
use the
see.
worst case scenario for refraction
Oh,
and
no,
then
no, no, no,
compare
no,
that
no.
to
Remember what I told you?
your
Remember
measurements.
I said you have to do this and that to account for refraction. Remember what I told you?
What was it?
And what all other papers will tell you. They say you have to measure the temperature gradient. If you don't know the temperature gradient, the vertical,
Well,
I'm
that's why I'm
sorry,
saying
the
use the worst
refractive
case scenario.
index is no,
Yeah, try
not
to
even
make
the
an
worst, the
estimate for
best.
that.
Do not estimate, sir. You measure it.
An estimate through your measurements. That's what I mean. Like try to
You
get a
measure
best
it.
estimate through your yeah,
Dude, you're
exactly.
What do
Through
talking
you
out
your
of
what are you
both
gonna
sides of
measure?
your face right now, bro.
no, no, that's how you do
Joe,
science.
you have a
Try and
No,
very
that's
big
estimate
not.
ego, bro.
measurements. No, I
Oh
don't think
my
so, man.
goodness.
Dude,
Okay,
you
Yes, you
so
do.
you
literally
You
just
measure.
can't
Taylor, I
stand
agree.
not being
Taylor,
a
I
front
agree with
pusher
you.
in
You
the room.
use measure. Taylor, I agree with you. You use measurements to make an estimate. I mean, don't you know what that means? You
Okay,
use
you
your
didn't say you
measurements, and
measure
this is
the vertical
experimental
temperature
science.
profile. You measure the
This
vertical
is
temperature
well, of
profile,
course,
and
that's what I
if you
mean. For God's
can
sakes, I'm a professional
pressure and
scientist. You're speaking to a person
really.
that has worked on fucking
The,
satellites before.
you
So if
said
you're in your
the worst
PhD,
case
you should
scenario.
speak to
really.
me on
She
that
said
level. You should
I'm
understand
that's
how
what
to
I'm
do
doing.
experimentalism.
Dude,
That's
I'm,
Taylor,
what
do
I'm
you
I'm
gonna
not
tell
know
you
how to
doing.
right
do
now, Joseph.
Taylor, have you even taken a physics
You say that you're
lab?
gonna affirm
No,
this
I want to know,
because you
Taylor, have
no
you
no
done
no
any
hold on a
physics
second,
labs?
Joe. You
Yeah.
say that the Earth is a ball because you work on satellites. Well, I build houses so the Earth is flat because I have to build all foundations flat. All right, so
Right.
that's the equivalent
The
of
Earth
what you
is
just
flat for
said
you.
right there.
The
You
Earth
said
is
I
flat for
build
you on that
satellites,
scale.
Earth a ball.
Well, the satellite is
I
launched
build
at high
flat
velocity
foundations, Earth flat.
to fall back to the Earth at the
No,
same
I
rate that the
literally
Earth
just did
curves
what you
away.
just did. Prove me
These are
wrong.
different
I have to
scenarios.
build foundations. Check your own
I
house.
accept both
Check your own
arguments,
house,
but
dude. I bet your foundation is flat. If it's not, you need a home inspector, and I'm a.
I accept both arguments, Brian. There
I need to
on
see
the
your
scale of a
GoPro
home, the Earth is
right at
flat.
the satellite.
You can make a flat home.
Hey,
In
Joe, do
any
you
case,
agree that physics scales?
not
Yes
linearly
or no?
always. Not linearly
No.
always. No,
So, so
there's
if I was
nonlinear
able to
differences between.
recreate the observed effect of an object being obstructed bottom up across a flat surface, what would you say?
Well, I would say you have to do what Taylor is saying, which is you need to account for all your variables, right?
Yeah,
Which
they
is what I
do.
agree with too. So you need to account for the variables as best as you can, and
So,
look at your
so hold
errors
on,
and look what your errors are. And
Man, you
I
gish
think you
gallop
do that.
around the question, bro.
Joe, do you
Go ahead.
believe that bottom up obstruction is exclusive to the globe solely?
No, you get this mirage effect. Everyone knows about the mirage effect, which can obscure things because of this. I mean, this is a well-known
Let's see what
phenomenon. This
So
mirage
isn't
it's
new.
is.
Like
so bottom up
Taylor didn't discover
obstruction.
this. Like this has
So
been well known
she
for
didn't say she
thousands
did.
or hundreds
She
of
didn't
years.
say
I
she did.
think in
Don't
the
put words in her
1800s
mouth.
it was computed. They started
Again,
being able to compute it.
it was a simple question. You're going on a tangent. Is
Yeah.
bottom up obstruction exclusive to a globe? Yes or no?
Well, I gave you the answer for that already. Come
Yeah,
on.
just give me the simple one. Yes or no?
Uh, is bottom up obstruction
Exclusive to
exclusive
the globe model.
to the globe model?
Is it
No.
exclusive to a curving surface?
At scale, at large enough distances,
At any scale.
Any
Remember,
scale
physics
ever.
scales.
And I will remind
The
you.
micro, the macro.
I would remind you of our little exercise where you said that there's no possibility the Earth could be flat.
well, no, there isn't. I mean, you have to factor in
Well,
so many
Bolivian
other
salt
things. Yeah,
flats are
there isn't.
10,000
the
kilometers squared,
answer
right?
is yes. It's not actually. The answer would be no. It's not mutually exclusive. You can get bottom up obstruction on both, and actually, flat earthers themselves have introduced temperature gradients and recorded things appearing to disappear into the ground. But I can give you papers by the University of Georgia where they actually talk about sinking refraction. Things would appear to drop and be cut off bottom up due to temperature profiles that are present along the surface of the earth during the daytime and even during nighttime too. But especially with sun out and stuff.
Yeah, so that's why you have to take sufficient measurements over sufficient scales and variations to map
Right.
all
So
that
the
out.
answer is that it's not exclusive to the globe, and you cannot say that the Earth is flat. Sorry, you cannot say that the Earth is a globe solely based on bottom-up obstruction because it's not an exclusive item.
I would say that if you factored everything in and did the experiment correctly, you would find that result.
I did it in my own warehouse across the 200-foot floor.
I did that
Who's got
experiment.
that one that Indio did?
I want
But
him
Taylor,
to
you
tell
said
me
that
what
your
I did
equipment
wrong.
wasn't. You said that your equipment wasn't accurate enough.
Are you
and
kidding me
couldn't
right
see
now?
very far.
That's not what she
Dude,
said at all.
He
You
did
said it could
not
only
say
work.
that.
you've got to
You
be
said it could
trolling
only work
me.
for a
He's
quarter.
got to
You
be
said it could
trolling.
only
This
work
is
for
the
a
most
quarter mile.
you're the most disingenuous guy.
It's not. She said her equipment
I
was only
never
good for a
said
No,
quarter
that.
of a
she
mile
never
based
said
on
her
Are you
equipment.
interviewing the other people.
She never stated that
I
at
can't believe
And
all.
she
he
said
said
she
that.
only did it. She said she only
Dude,
did
she
it over a
literally
mile.
said she got the best that money could buy. She's got $1,000
It's a
theodolite.
good. It's what
What she said
surveyors
is that
use.
Yeah, but
surveyors
these are
say
for
that you don't
surveying
want
for
to do it
buildings.
long
What are they
distance because,
surveying? They're surveying over
dude,
short distances.
dude, I don't know why you want to sit there and just talk over people, Joseph. You don't listen to anybody.
He really doesn't. The fact that he thought I said that is crazy.
Yeah, and to
No,
claim up here and
it
claim
has
you're a
nothing to
scientist
do
or
with better
you're a
equipment.
complete sham. You pretty much declared on multiple occasions that you don't understand the scientific method and don't respect the data. So, I mean,
I think I
I
just
just assumed
said
you're
we
just a
need to
complete
defer to
liar
science
and
and
that you've never
sufficient
worked on a
measurement.
satellite in your life. And I'd like to introduce the concept of satelloons and I'm going to call you out. You're a complete liar.
Peekaboo
You're a
balloons.
fraud.
Well, I'm
Okay,
sorry
yeah.
Don't
to
talk
hear
to
So
Taylor that way.
yeah, this equipment that I use, which is survey grade equipment, by the way, all certified and tested to make sure it's all calibrated and all the above. What is equipment that surveyors would use and would consider good equipment, and it's like pretty up there in terms of accuracy. But by the way, that's not really the problem whenever it comes to surveying, because you can easily see things over a mile. This is the normal range at which I normally measure. Now, a magnifying glass, like there's no limitation to how far you can see stuff, and except for like the atmosphere being in the way. It's not like the equipment itself is gonna fail. Okay, you just start being able to not distinguish different objects and items once you get further away, because there's more atmosphere in the way, because the resolution is lower. You can't, resolve different things once you get at greater distances. And then also refraction is cumulative, so you're going to have those errors introduced as well. So this is why surveyors normally do short distances for accuracy. Okay, so I'm trying to be the most accurate, and that's exactly why I did what I did. I didn't have an instrumental error or anything like that. I did the
Right, but
best I could.
short distances mean that you won't be able to see the curvature very
You
well. So
should
what
be
is
able
the
to.
error?
8 inches.
What was your error? What was your error computation on your measurements?
My standard deviations on my
Are
chart.
you even genuine right now?
What was it? What was the value of it?
It was like a few arc seconds.
Okay, what is that? What does that correspond to in feet or whatever? At what distance you were measuring in inches?
I
At
would say
whatever distance you were measuring.
less than an inch, and I was measuring like 9
So a
or
few
10
arc
inch
seconds.
drop.
Well, let's calculate it. So what was it? What was your standard deviation error?
I can pull up the spreadsheet. I've already posted it.
You don't remember it? You don't. It was your experiment. You don't remember the value?
I did 3 trials, and no, I don't have every number on it memorized.
Okay. Well, what was it? You said
Okay,
it was a
tell
few
me.
arc seconds, 5 arc seconds you want to do, or 3 arc seconds, or what?
I'm gonna do what the spreadsheet says. So I'll drop it in the
Okay.
chat, and you can tell me what I could
Well,
do better.
tell me the value
If
so I
you
don't have
have
to put it in the
any,
chat. Tell me the value of the standard deviation.
if you have any like advice on how I could have done anything better to your liking, let me know. But in terms of a longer distance, that's gonna make the error prone abilities much higher. You're gonna be much more you're gonna have a much higher ability to encounter error
Yeah,
than you
exactly.
will
Which,
under short distances. So
yeah, because
you
your
can
equipment isn't very
easily
precise.
no, the equipment can easily differentiate 8 inches over 1 mile.
You
Easily.
just said it's a few arc seconds, right?
I have the answer here. It's actually the standard deviation on run 3 was 0.8. I'll tell you that. Let's see.
You say
Trial
a third of an
2.
inch.
Standard deviation, trial number 2, 0.50 inches.
How many observations were done to get to
So
that?
half inch,
3 and
half inch deviation
left.
max.
I did face left and face right 3 times for each trial, and I did 3 different trials on like different days, times a day.
Trial number 1, standard deviation 0.78 inches.
Well, the common
Okay, so we
quote
almost
in
got 1/2 inch.
experimental science
That's 1 mile.
is poor methods and poor equipment give positive results. So I would say
What
that.
is the poor method?
Well, I would say
What
you,
is
you
poor
actually you
equipment?
actually don't have a degree yet, Taylor. Like
You're a
you're actually
fraud.
just
Hey,
You're a
doing
fucking
this still.
Joe,
I
fraud.
mean,
hold
you might
on
not
one
You're a fraud.
second.
you might not
Joseph,
be
you're a
doing the
liar and a fraud,
experiment
and you're
very
a
well.
disingenuous piece of shit.
Men
I would say
punching
she's
down.
Joe,
just
what
wants
is
to
your
struggling
hand
to
wave
know
it.
how to do the
experience?
experiment.
What is your experience with the Theodolites?
He just wants to
What
hand
is?
wave it. It's all good.
Well,
Yeah,
I
I want
think
to know his
she
personal experience with the
I think she
Theodolites.
might be too amateur. She
Joe, I
might
asked
she
you a
doesn't actually have
question.
a
What
degree. It
is
sounds.
your personal experience with the Theodolites?
I would
A
say it's about the
lifetime of
same
pattern
that Taylor
recognition.
has, which is next
Either
to
So
way,
nothing.
we live in a
you
Okay.
non-local
utilize
universe,
Theodolites
so
You got to
personally
mute that.
it's
Come
all
on,
an
Lily.
illusion.
Don't be a trolling. All right. So in
because
terms of
he's arguing from ignorance here.
yeah, I know. That's why he's even bringing up these things, because he doesn't fully understand. But if you have a better experiment that was done with the theodolite proving curvature, please bring it forth. Do you have a better experiment using survey equipment proving
Sure, in
curvature?
2003, the
Please cite
Nobel
it.
Prize winners proved that quantum entanglement is real, and we live in a non-local universe.
Okay. Anyway, so Joseph, do you have an experiment using survey grade equipment that can show that the Earth is curving? That accounted for the variables or whatever. Hopefully they did if they're actually trying to be accurate and read papers.
And
But yeah, provide your evidence.
they're
So yeah,
posted too as well, the spreadsheets. So go ahead and have a look. See there, Joseph.
yeah, I'll have a look. I'm sure that they're done incorrectly if that's what the
Oh, I'm
conclusion
sure.
is, or
I've been
Wow,
That
that's quite
insufficient
the
shows your
assumption. See, this is where
bias.
we're coming from.
because
That's quite an
because
assumption.
you
Bum,
worked on
bum,
it.
bum.
What
Well, that's
exactly did
because
you
there's
do
so
on
much
this?
other evidence.
Bias.
It's because this is one silly
What
experiment
evidence?
done with poor equipment over such a
This is
small
the best
distance.
equipment
No,
you
it's
can
not done with
get.
poor
That's pretty
equipment. It's done
sad,
with
It's the
Joe.
best
professional equipment.
equipment for small distances, Taylor. It's the best
You
equipment you
wanted
can do for
small
small
distances is
distances.
better. Do you not know how
That's
surveying
ridiculous.
works?
That's
The fact that you're
ridiculous. Yeah,
telling me small
surveying for small
distances.
distances. The curvature, you
They
see
would
more
tell you it's
curvature over larger
inaccurate over
distances.
large.
You
Dude, you're
see larger
tripping.
curvature. There's larger
Joseph,
curvature over larger
Somebody's
distances.
got to tell this dude. Larger
You're
distances
using
means less
His,
accuracy in
his
surveying.
his
That's
ego's
because your
standing in his
equipment
way.
isn't very
He's
He can't
precise enough.
trolling. He's
That's because your
trolling.
equipment isn't.
Oh,
all right. You know, Joseph, you're just hand dismissing everything away, and it's just you just look sad and pathetic at this point. You're I can't I don't even have the words for how disingenuous you're being right now.
He
It's
sounds
really
offended and threatened. He's
I
not the
mean
smartest man in the
seriously.
room right now.
He's totally not the smartest man. I mean, seriously, he's trying to call everybody stupid, but he doesn't even know how his own freaking ball works, man. You don't know, you don't understand the drop over.
Well, I've seen no evidence against it so far, aside from poorly
well,
conducted experiences
What did
with
I do
insufficient
poorly?
equipment. With insufficient
You've literally
equipment that
offered no
people don't
evidence
know how
for
to
it.
operate by
Guys,
Listen, let me
amateurs.
respond.
The evidence you've
By
offered for
amateurs
it
that
was just
claim to be
disparaging
going to school,
comments.
but it's not clear what they're
Okay, here's
actually
a
going to school
peer-reviewed
for.
paper.
Taylor, what are
Here's
you
a
actually going to
peer-reviewed.
school for?
Excuse me, sir. Here's a peer-reviewed paper from people who did go to school, and say that
Oh,
you're
good.
gonna do
Institutionalized
roughly 10
academia.
meters,
There's our
so
answer.
a few hundred meters maximum over surveying, like over from one shot to the next. Okay,
Taylor, if you
so
can't even understand that a larger signal is better for experimentalism rather than a
No,
small
it's not.
signal, I
No,
don't
it's
know what
absolutely
it
not.
could
No,
be.
listen,
Joseph.
I
signal
mean,
to noise ratio.
that's what it's all
Do you know
about is
signal
signal
to
to
noise
noise. You want
ratio?
better
Okay, so
signal.
the refraction's
Longer
noise.
distance gives.
It's obvious that at this point he understands that a long distance is increased error. In other words, you can't be sure, and that it's much more accurate at short distances. Yet he's going to persist in this direction, telling you that your equipment is inferior. You need better equipment. And I'm willing to bet he can't even tell you what equipment is better. He's trying to piss you off. That's his aim. That's his fucking goal. He's got nothing else for you.
They did this with Dr. Hepron as
You're
well with his celestial
mischaracterizing me
theodolite.
Oh
entirely.
goodness.
Like, I'm not raising my voice and I'm not using ad hom.
You've offered
No, you're just
literally
very
zero evidence
condescending in your speech.
I'm not condescending. I'm sorry you find it
Yes,
that
you
way, but you
are.
want
Yes,
a
you are. You
larger
were
signal.
literally
A
telling
larger
Taylor
signal
that
is
she's not a
found over
PhD
larger
and that she's
distances.
basically not
It's
equipped to have this
fine. It
Well,
discussion.
doesn't
she
matter.
won't
It doesn't
answer.
matter. I'm about
She
to give
won't
him a peer
answer
reviewed
what she
paper.
actually is. She won't answer
Excuse
what
me, sir. Can I
expertise
give
in
you this
science
peer
she
reviewed?
actually has.
I've already mentioned I've mentioned it multiple times. I have a bachelor's in biology, minor in chemistry, but I do enjoy doing experiments. If there's some method, it's something with my experimental methodology that would be better. Let me know, because you know the Globers actually gave me the idea of doing this experiment in the first place and told me which theodolite I should use and
I
X, Y,
appreciate
Z.
you so
So
much.
actually use that method, their methods. And so anyway, here's a peer reviewed paper. Here's a citation that says, for precise work, try to keep the sight lines under 300 to 500 meters unless conditions are excellent, but still you want to keep them less than 500 meters. And for layout and
Like I
rough
was saying.
grading,
So it's short
let's
distance
see.
equipment where you
Yeah,
wouldn't see the
short
curvature of the Earth very
distances.
well. So that's what
For
it's for. It's for
surveying,
short distances where you're not going to be able to see the curvature of the Earth.
no,
Did you
they
say the
say
curvature of the Earth is always curving there, Joseph?
it's supposed to always be curving, so it doesn't matter.
Yeah, but you're not going to see it over such a short
You can
distance.
pick
Oh yeah,
up,
you know
but
what? You know what? You know what?
my
There should be
theodolite can pick up 8 inches of drop over 1 mile, easy. It's well within the range limit of what it can pick up in the tolerance. So it should be able to pick up 8 inches over a mile easily. So why wouldn't I do the shortest distance to actually rule out more error and like
Well,
lower
why
my
don't you use
signal
1
to noise
foot?
ratio?
Could you use 1 foot, Taylor? Like, would it make sense to use 1 foot or 1 meter? Like, would it make sense then
Yeah,
if
go ahead and try.
you're saying shorter distance would be
If you have
better?
accurate enough
That's
equipment, I
absurd.
had accurate enough
That's
equipment.
absurd,
I
Taylor.
had accurate enough equipment and still do that can measure an 8-inch drop over 1 mile.
Yeah,
But the
you
thing
just
is,
said that you
I
could go
wanted
to
to
0.
actually calculate for refraction. What the point of my experiment was to do surveying where you actually do what the Journal of Surveying and Engineering says to do and account for the temperature gradients. And I did the temperature and the humidity the pressure and humidity gradients to try to account for refraction in my observation. That was the point of doing it. Okay.
That's what it's about.
Your videos up top.
And since it's cumulative, the errors that can be, it's error prone because there's error and other things that can make things appear to drop or, raise in vertical displacement. You're going to keep it the lowest limit that you want just for the most accurate results. If my instrument can easily pick up 8 inches over 1 mile, then why not do that if it's the least error prone way? And plus, you mentioned earlier, terrain. The longer terrain, the more chance that you have for going over, having terrain differences as well. So I want to keep it within a span that I know that the terrain is not going to deviate within 1 inch. Do you understand?
That's probably why you should do it over water, probably. I'm sure that
Okay,
there's
I mean,
experimental problem. I'm sure that you're running into
That's hilarious.
experimental problems there.
Water
so
lays
what could
level.
I have done better?
Do it over water.
Why do you want to
over
do it
water
over
next
water,
time.
Joseph?
Why they tell me not to do it over water?
Yeah,
Hold
water
on a
lays
second.
flat anyway.
Hold on a second. I got a question.
Aye,
Why do you want to do it over water, Joseph?
I think you would, because then you don't have problems of elevation changes due to just geography.
She's on the salt flats, dude.
What,
Do you know what that
Well, those
means?
could have them.
What do you
Those
mean?
could have it
The
too. Yeah.
water wasn't going to change elevation? What does that mean?
So she's trying to say that the Earth is round, or what?
Hey, Holcomb or whatever your name is, I appreciate it. So what does that mean that the water isn't going to change elevation, Joseph?
I mean that on ground you can have, non-spherical Earth caused elevation changes or elevation constancies, actually, even due to just
Okay,
due to
well, I did
geography.
LiDAR scans.
I'm asking
he
about
won't.
water, Joseph.
He's not gonna say water lies flat. He's just not gonna say it.
Even
Joseph,
we just did.
No,
Even
the
though we
water
just-
water
even
doesn't
when-
You're
like
gonna have
that.
to
The water
prove the
will,
water
the
holds
water
to
will
that
Joseph.
surge.
temperature.
My man,
Yeah, the water will-
Joseph, do you understand the process of sedimentation?
Yeah, but I mean that's not
Yeah, but
guaranteed
what?
to be perfectly flat. That's not guaranteed to be.
Well,
perfect.
that's the point. Is it's not across the entire park.
Or
I think it
it could
drops a
be
couple
perfectly
inches,
flat, and
maybe.
it's actually more
The,
flat
the
than
water's guaranteed. The water's guaranteed to be perfectly flat.
So Taylor, like you cited it before. What was the total drop across the park? How many inches was that? 8?
Yeah, and within the
And
range
how
of like
wide is the
30
park?
miles. It's
There you
like
go. 8 inches
60
over
square.
30 miles. That's what GPS says the drop is.
The LiDAR scans, yeah.
Uh-huh. Okay. So she's doing 1 mile
Yeah,
at a
so that
30th of
geography
the
there
8
could
inch.
be
And it was the
artificially flat.
flattest spot of everything, yes.
Yeah,
Of
I
all
mean,
the
it could
LiDAR
be
scans, it had the
artificially
least.
flat.
What do you mean?
It could be flatter than it's supposed to be due to geography.
There would be a 1/4 inch drop over that mile due
Yeah,
to
but then you would have seen the
drop of the
elevation
park.
raise around, like there would have been like a circle of higher elevation in this. If you're saying like it's not curving like with the Earth, there would be something that would have to account for that, like raising it up along the edges or whatever. But there was none of that. It was
Well,
all,
sediment could do that.
smooth. No, it was
Sedimentation could do
smooth.
that.
Well,
That
that's
didn't exist on the
sedimentation.
LiDAR scans.
That's why I was asking you if you know anything about it, Joe, because that's the point, is that it wouldn't do that. It would absolutely
Well, it could.
flatten out
Geography
over and
can do
over and
crazy
over
things.
and over, day to day, week to week, season to season. The process repeats. It wets, it dries, it wets, it dries, it wets, it dries, and it all forms completely flat. That's the point.
Yeah, and it was
Yeah.
salt, so it
So
can't
therefore,
dissolve.
it's
Yes.
artificially flat, and it's not seeing the curvature of the Earth on that scale.
Okay, and you're going to suggest that water
No,
is
it's
laying
everywhere.
artificially flat.
That's why we
They
should
Okay,
use
call it the
water.
salt flats because flat
dude,
all around.
That's why
I
we should
just
use water.
described the natural process, and the first adjective out of your mouth is artificial.
Well, there's
Wow.
Do you know how long
geographic
the salt
effects.
flats are there, Joseph?
Fucking wow, Joseph.
How long? No,
Do you
I
know how
didn't say
long?
artificial. I said it
Do you
would
know
be
how long the salt flats
artificially
are, Joseph?
flat.
That is
How long are
exactly
they?
what you said.
I'm asking you. Do you know how long they are?
The salt flats, which ones in Utah or wherever the fuck
Yeah,
they are?
the Utah ones, not in Bolivia. We're in
Oh, I
Utah.
don't know. I think they're pretty long, aren't they? Don't they go
Pretty
on
long,
quite a
so
while?
you don't really know.
I don't know. What is it, like 100 miles or something?
No, they're 12 miles.
Oh, is that it? Just 12?
Yeah,
Yeah.
yeah, that's it. 12 miles, and by 5
Yeah.
miles. So there's plenty of Earth curvature that's supposed to be there. You do
Well,
realize that?
she's not doing that long. She's doing a much shorter
Yeah,
distance. So
yeah, but the
she
salt
do it over a
flats
longer
in of
distance.
themselves curve, right? It's 12 miles. You should see curvature in 12 miles, right?
Yeah. Well, I would suggest doing the experiment over that range.
Yeah, yeah.
No,
Doesn't that?
no.
Didn't you
Any
just?
surveyor would not do that. That's
Didn't?
stupid.
Yeah,
What did
exactly.
the
But
lidar
didn't you say,
say?
Joseph? Didn't you? Hey, Joseph, when we were trying to establish the tangent line, didn't you say that the Earth starts curving at your feet to the tangent line?
The Earth is, yeah.
Yeah. So what? Yeah, the Earth is. What do you think
Yeah.
she's measuring?
Well, she's
If
measuring
the
the
Earth
local
is curving
geography.
starting at your
She's measuring
feet,
local geography because
if
she's
the
doing such a
Earth is
small
measuring
distance.
at your feet over a half mile, there should be some deviation in the Earth, correct, from where you're standing?
Yeah, but there's geographic variations over such a small scale.
Dude, she said she did LiDAR scans there and went to the flattest spot.
Yeah, there was
Yeah,
definitely
because
less than
it's
a
flat. So
deviation within.
she's
I
starting with a
promise you,
flat
based
spot. I
on the
mean,
LiDAR scans,
she's
the
assuming the
oh
goal that
my
she
gosh,
wants, right?
Dude,
are you
you
kidding? No.
And you're
Oh my gosh, dude,
you're
listen.
choosing a
I went
spot
to the
that's flatter
yeah,
than
so
it
we can
should
get the
be.
curvature, so we don't have terrain interrupting the
No,
curvature,
you're
bro.
no. See,
Right?
that's about a
Yeah,
bad
okay, so
experimental condition. You're
actually,
choosing a
the
flat
Bonneville
spot
Salt
to
Flats
measure
are
from.
actually 46 square miles. Okay, the
Yeah.
national park, but the U.S. national, but they actually have like some military base on the right side, so you can't actually access that part. So it's not like the park. So whenever I mention the LiDAR scans, I think it encompasses a much wider range, but the public doesn't have access to. It's like the right side of it when you're driving to it, from like I think the Nevada side or something. So yeah, so the entire park had like from memory, like 8 inches over like the entire thing, even encompassing where the military base was and everything. But within the range that I was doing it within the location, it was much less than 1 inch deviation.
Mhm.
You understand? Based on the LiDAR scans, there was no like rises or plateaus or anything. All
Yeah.
around it's flat, but this was like the smoothest of all the LiDAR scans.
So you have a small area that's flat already, and you're confirming that it's flat. Like that's kind of like assuming what you guys always say. You're assuming what's.
But they say the LiDAR
Wow.
scan has the curvature, like the LiDAR scans, like basically account for the curvature because whenever the drones are going over the land, they're keeping the same altitude and elevation. So this is why they say, oh, like it's already accounting for curvature because the drones are keeping a steady altitude, and at a steady altitude, the drone would be curving. So do you understand why? Yeah, that your point would be debunked by that.
Well,
should
I
be
think
like
that's what you're
96
saying,
feet
but
of
you're still
curvature at
doing it
12
over
miles.
such a very small distance.
There's very small distance. It makes it less error prone, less topological errors, and less refraction errors. So you're just wrong.
No,
Oh,
that's
but he's
not
also
true.
he's not even
You need
accepting
higher.
the
You
lidar.
wouldn't have more
Is
refraction
the
and
lidar
more
data is the
topological
lidar
errors over longer
is the lidar
ranges.
data
That's a
not
stupid
enough?
statement.
Is the lidar data not enough large enough measurement?
Huh?
Well, Joseph, you've offered zero evidence to support your claims. So I'd like to just mention that, Mr. Scientist.
I would like him to refute my experiment or whatever and tell me how I could do it better. He tells me to do something that's going to introduce more errors, though. Why would I do that?
Well, I think you don't have a full comprehension of experimental science. You want better
How
signal
so?
to noise. You want
Look at
higher
the big
signal to
brains
noise.
on
You get
Brad.
better signal with a larger distance because you get more
You guys
curvature.
here to gaslight, right?
Okay,
No,
listen.
You get
Right?
more
The
noise over a
signal.
Now,
larger
if you're
distance.
if you're
Yes.
saying that
Okay.
your
So
equipment, if you're saying that your equipment is incapable of doing that, it means
I
that you
didn't
don't
say
have
that. It
sufficiently
is
accurate
capable
equipment.
of doing it.
You keep
It
saying that.
is.
You keep saying that my equipment would produce
The
more
equipment
errors if I
is.
went to larger distance. You keep
That's
saying that
because the
over and over again.
atmosphere. That's
You
because
keep
the
saying over and over
atmosphere.
again, my
That's
Taylor,
equipment
because
can't
the
measure
Taylor,
atmosphere.
larger
don't
distance.
interrupt Joseph Mingler, Dr. Joseph Mingler.
Joseph, you're not even paying attention.
I am paying
Seriously.
attention.
No, he's not. She's told you many times the equipment is the best equipment you can
For
get.
short distances.
You're not going to go out and get more accurate equipment. It's the atmosphere that increases the error
She
rate.
has equipment for short
It's the
distances.
distance.
So, Taylor,
Okay, so
by
what
your
about the lidar?
hypothesis, is the Earth flat or is it round, Taylor?
It's flat. It's flat.
First gums.
No, Taylor thinks it's flat. Yeah.
Well, it's flat because of the measurements. All the measurements suggest it's flat, right? You're assuming.
I want you to look
You're
at my
using
data. You can come
assumptions.
to your own conclusions.
Yeah, you're using assumptions, Joseph.
But yes,
to come to
when
conclusions.
you account for refraction, I found it to be closer to the FE prediction without any genuine rebuttals. Saying I should introduce more error is not a rebuttal because guess what? The signal has a consistent ratio, drop over distance. That's consistent. Guess what? The noise is going to get higher, and you can't account for it. So yes, while the signal may be higher, the noise is exponentially higher, and you can't account for it. Do you understand? You're going to have more topological changes, more temperature variation within your line of sight that's not accountable for. One thing that is consistent though is the signal, which is the drop over distance, 8 inches per mile squared. So whenever you have a higher noise ratio, whenever you go to higher, longer elevations, but you have a consistent signal, then the smartest thing to do would be able to tell between the signal and the noise in the least amount of errors as possible, with a method that would introduce the least amount of errors as possible, which would be something that my equipment can detect easily, which is an 8-inch variation over 1 mile. That's extremely that's like child's play for the theodolite I have, right? But over longer distances with any theodolite whatsoever that you can buy anything in the whole world. You cannot account for the atmospheric variation that you have that's introduced between the observer and the target. I really hope you understand this concept and stop repeating it.
Yeah, I'm just seeing lots of references online of using this theodolite method, and they're simply not agreeing with your results. That's why
Can
I'm
you
just
cite it? Because
concerned.
I'll cite mine that I
That's
do
why I'm
agree.
just
Yeah,
concerned
Give me your
put it in the
about.
nest.
citation,
Put it in the
please. I'll
nest,
give you one
Joseph.
right
Put
now.
it in the nest. Put it in the fucking nest, Joseph.
Yeah, please.
So full of shit. You don't
Yeah.
have shit right now. Put one thing in the nest.
So
I dare you.
Taylor, by your measurements, do you think the Earth is a cube? Because a cube has flat sides.
I'll drop this in the chat right now. With the surveying techniques. And you drop yours that's saying that I'm wrong, okay?
Yeah, God, I know. I hope you drop the experiment that I think you're going to drop, and we're going to have a nice little conversation about how that data was corrupted and the story behind that.
I don't know what you're talking about, sir. I'm sorry.
Oh, Joseph, the original Theodolite measurements that were taken with the 13.
We're talking about how to do accurate surveying measurements. So hopefully he's going to drop some surveying
Exactly.
manual or something.
Oh no, it's just a basic
No,
website
he's going
I
to
have
drop a
here.
conflated. He's going to
But
drop
I
a
would just say I'm
measurement.
very concerned about Taylor's competence. She's not an actual experimentalist, not an actual
Dude,
scientist, not
flat
actually
Earth,
trained in
You ain't
physics.
shit. You're so full of
Very,
shit.
very concerned about her
flatearth.ws is a bunch of clown show.
competence here.
What?
That's ridiculous.
No, this fool did not quote
flatearth.ws.
that.
Oh my god.
That one's pretty good. Well, it just kind of
You're
demonstrates that
such a
she's
dropping
likely
McNuggets
clown.
not
site.
doing the experiment the correct way. She doesn't understand what she's
Do you know how to
doing.
get to primary sources? Are you a scientist, Joseph? I was going to give you primary literature. And what are you giving me?
Yeah.
You should have learned about primary
giving you-
sources,
Well,
right,
I'm
in
trying to
college?
help you learn how
He's
to
giving
do
you a website
scientific
that's not backed up at
Gaslighting,
all by
buddy.
any
Oh my
academia.
gosh.
He's offering you conjecture, or was that what it's
Okay,
called?
so Joseph, and if we're
Gaslighting.
going to talk science, we need to use like peer reviewed papers, right? Not like some whatever that website was.
Gaslighting.
No, not always.
Let's just okay. Well, is that your standard with scientific? I'm trying to hold to your standard. What is your standard?
Well, I don't think that
This guy doesn't have any standards.
Peer reviewed. There's peer reviewed papers for refraction that does not support the whole Earth being flat. There's no peer reviewed papers for the whole Earth being
No.
flat.
I'm
So
asking you
you
for a
can't
peer
really
reviewed paper that
refer
you
to.
should do longer distances to find the curvature of Earth. Is that what you're proposing? I'll show you that
Well,
in
see,
surveying, it'll be more accurate over shorter distances. I can easily cite that.
There's only
No,
one way
your
to solve
device.
this.
No,
You
no.
got to go to
See,
Antarctica.
Samantha, this, or not Samantha, Taylor. See, this is something you don't understand about experimentalism. It's saying that your device is more accurate over shorter distances. That's all because you have an inaccurate device.
Any device, dude. This is how I know you don't know what you're talking about. Any device you cannot. What? Okay. Which theodolite's going to account for the amount of atmosphere introducing air over longer distance? What?
Did she drop?
Did we lose Taylor?
Sound like it.
Oh man.
She's out there in the field with the ruler and measuring tape, and you guys are making her. You're mansplaining.
She's killing it.
Joseph, you're not bringing
She's
anything
the
to
best
the
of us.
table but a bunch of nuh-uhs. You know that, right?
I would say not. I
You
would
come
say that
on to the
you're
McKinney's
focusing
website.
on refraction over very
Joe,
small distances.
have you reviewed her data
You have
sheet?
a very niche, very
Have you reviewed her data sheet?
narrow
It's posted at the
argument
top.
here.
Have you taken a second to look it over?
Okay. So because she's accounting for the variables, and she is accounting for the variables, you're saying this is a problem.
I have no reason to trust her competence or her data.
I have no
So you're
reason to trust
insulting
Nobody has any
her.
reason
You're
to
saying
trust
she's
you
not
on
competent
anything.
enough. So you're insulting. You're condescending. You're a piece of shit. Honestly, go look
Yeah.
up there and
Right.
read the data
I
sheets.
completely agree.
I'm sorry. Yeah.
What exactly did you do on these satellites? Twist a screw, or file paperwork? Because you got way too much condensation in your voice there for you to actually be this smart. All you're bringing to the table is nuh-us. You really haven't brought anything.
Well, we're trying to discuss experimentalism. She doesn't
Imagine
seem to
being in a
understand very
classroom with this
basic
clown.
concepts.
Oh no,
So-
no.
She thinks
She
that
does
the
understand
device
it.
would
And
be
I
more
think you're
accurate
trying to.
over
No,
1
she
foot.
does
She
understand.
thinks
She does
that
understand
she
it. You
would
don't.
measure the Earth's curvature over 1 foot the most accurately. I mean, it's absurd. She has no concept of how to do this experiment. So I
Have
tried
you
to
looked
link a
over the data
website
sheets, my man?
that
Have you
explains
looked
how
it
to
over?
do it.
Have you looked over her data?
Yeah, but I think that the
No.
distances.
I ask you a question. I
think
don't
she's
care
got.
about what you think. I don't care about what's in your head. Have you looked over
Yeah.
the data that she presented?
I'm looking at it now. I think she's
You're
got
looking at it now?
geographic influence in there that's messing with her
You
data.
think that based
You don't
on
even-
your personal
this-
experience?
Your ego is a massive, such a big inflated head, Joseph. Wow.
Yeah.
Hey,
I
come on, don't be
guarantee that
mean,
this
guys.
man is not married. Joe, are you married?
Yeah,
You are? Holy
Yeah.
crap. How did your wife put up with you?
she's fucking tall, blonde, Swedish girl with huge tits and fucking beautiful. She's
Ah,
like,
you're
wow.
you're a,
Now we
you're a
totally believe it.
misogynistic man. Ah, you're
I'm
one of
just
those
saying,
guys.
she's fucking beautiful. She's
And
a,
everybody believes it.
Yeah, this explains it. You don't like getting schooled by a female. He
My
explains it.
wife tells me what she wants to tell me whenever she wants to tell me.
You're getting schooled by Taylor, a younger girl at that too. Um,
She's not
and
though.
you
She
don't
doesn't
like
seem
it.
to understand
You don't
basic
like it.
experimental.
No,
She
she
thinks that
understands
she
it.
could
She
measure.
understands
No,
it
she does.
just
Well,
fine.
She's
Believe me,
accurately.
she's
one foot.
debated people far superior to you.
I said,
You
Taylor, would you be
understand
able to
that?
measure the curvature of the Earth at 1 foot the most accurately? And she said, yeah, you would. I mean, it's absurd that that's how this experiment would work and or be more
She
accurate,
said
most
one
accurate.
foot. None of
That's
us caught
absurd.
that.
Well, she did, yeah.
You keep putting words in her
Yeah, I don't think
mouth.
that happened.
It's
I don't think
funny.
that
No, I
happened
didn't.
either.
I didn't. She did.
She kept referring to her measurements that she took. There was
Yeah, and
never a reference
she
to a
was
1 foot
saying it
measurement.
worked best over shorter distances. I said, well, would it work best over foot? And she was like, yeah, it would.
Less error,
That's
Joe.
absurd.
Yeah, there would be
She's
a zero error.
reiterated
Yeah,
this to you multiple times.
You need to have enough signal to
You're
that's
just
actually
signal.
measure the
mentally
curvature, though.
capable of
She's doing it over
accepting
too short of
the
distances.
opposite of what you believe.
So
So
anyway, seeing how you think bottom up extraction can only happen on a globe, I put a post up there in the nest that shows that it actually can happen on a flat Earth.
yeah, no, I agree with the
Yeah,
whole
yeah, yeah.
mirages stuff.
So
Yeah,
so that wouldn't
mirages. Yeah,
be
I agree
so
that
that wouldn't
mirages exist.
can you hear me speaking, Joseph?
Just getting that in there, Brian.
Can you hear me speaking?
Yeah, I can. I thanks for the
So
moment
when
to
I'm
just get that in.
speaking and you overtalk me, can you hear me speaking when you're overtalking me?
Yeah, I can. I really
Well, I
appreciate when I
can't
can
hear
get
what the
something in
fuck
there.
I want
Well,
to
you
say,
just
and it's
asked me a
very
question, so I was trying to
distracting.
finish
So
there, and
as
then
I'm talking, Joseph, why don't
yeah.
you act like the fucking mature guy you think you are and shut the fuck up?
No, it's
All right?
okay,
I
Brian.
seriously, you've been over talking everybody all fucking night, and this is why you still are fucking lost and you think Taylor said something I doubt she even fucking said. All right? But anyway, if this can happen on a flat earth, then it's not globe exclusive. So your whole bottom up obstruction, saying it can only happen on a globe. Well, that's just been busted.
No, as
No,
I tried to explain,
as I said, I put an experiment up there that shows it can happen on a flat Earth, bottom up obstruction, and yeah. So that means it's not globe exclusive. So that's not exclusively for a globe. So therefore, it can happen on a flat Earth, and you're going to have to come up with another argument.
to Taylor, you need to take into account all the
No,
different
no. As
factors.
I tried to
And I think
explain to
that
you,
if you
there's an
properly did
experiment up
that,
there.
that you
There's
would
an
discover
experiment
over a
up
large
there.
enough scale.
You keep on trying to put parameters in there that you think need to be there that they don't need to be in there. All right, whatever it is you think needs to be in there, it doesn't. I told you there's an experiment there that shows this can happen on a flat Earth. All right, a flat plane. All right, that means it's not globe exclusive. All right. And the fact that we can replicate it on a flat surface means it's not globe exclusive. No matter what kind of caveat you want to throw in there, it can happen on a flat plane. It's not globe exclusive. These are the facts of the matter. All right. You trying to obfuscate away and try to say, oh, well, you didn't think about unicorn farts. That's not going to cut it. All right.
Well, in experimentalism, you try
He's
to
not
account
even
for
giving
all
another
factors.
experiment. Like that I like okay, so can you give me the optimal experiment that would be done to measure and that would also account for the variables properly? And my phone died whenever I asked you what instrument could I use to account for atmospheric refraction, which in many cases can actually cause more of a vertical displacement than the expected drop over distance. Okay, so which equipment should I use to properly test this?
You should use appropriate equipment. Here, I'm just posting something. My internet is
Hmm.
fucking being really weird
What do you have
and
any
slow.
clue? Just give me a description of what equipment I should use to properly test it.
To properly test it, let's see. Here, maybe this YouTube will work. There's another one. Why there are no flat
A
Earth
YouTube
surveyors? So
video?
this,
What are you
yeah,
what
this
are you
channel
talking
says
about? A
that
YouTube
there are
video.
no.
Just answer the question.
Yeah. Sorry, what was your question, Taylor?
What equipment do you think she should be using? You keep saying her equipment's no good, so name a better piece of equipment.
Well, surveying is generally done over short distances. So,
She
whatever
didn't
the
ask you what it's generally done over. She asked you what better piece of equipment should she use.
Probably maybe a telescope or something, or a camera, a better camera.
Wow, you're a fucking idiot.
Okay.
Over
You're a
the
complete
Wait,
fucking
wait.
idiot.
I
Get the
unfortunately I
fuck
missed
out of
that,
my
dude.
face.
You said you should use a camera or a telescope.
What?
Yeah,
Do you know it has a
better,
telescope on
better.
there? It has 30x magnification, dude.
Yeah, but only a 2-inch aperture, you said, or 1.5-inch aperture. I mean, that's not very
What do you
good.
want me to
It's not going to be
use?
very
I'm
accurate.
using surveying equipment, sir. What should I
Yeah,
use? How am I going to measure?
What do you know
How am
about
I
the
going to
Adelaide?
measure the vertical displacement?
you should
What do you
use something that's better for longer distances.
what
As
do you
you
know
said,
about
Which
the
the
is
Adelaide?
surveyors,
what is that? You want to hook a rig up of a
No, it's totally
telescope
fine, Joseph. Just
onto
tell
a
us the tool.
theodolite?
You know what?
Tell me the
Taylor,
equipment.
hold on. Taylor, hold
yeah,
on.
sure,
Joseph,
maybe do that.
Joseph, just tell us the tool that they use to measure the curvature.
He wants her to use Hubble,
Please.
obviously.
Huh? What tool do they
I
use
want him
I think
to
to
they
measure the
use,
curvature of the Earth?
from what my understanding, they're using what Taylor's using, but they use it with better expertise. I don't think Taylor knows what she's doing with it.
What
No,
did
they
I do
don't. They use it
wrong?
with less, and that data is corrupted. We're going to go over this whole fucking thing again. This is why we got a Theodolite in the first place,
Yeah.
because that data was corrupted, and everybody fucking knows it.
Hold on a minute, Jack. I got a question. What do you know about the Adelites there, Joseph?
What do I know about them? I know that they're used for surveying, and they can view the horizon and measure. If you use
Have
it
you ever
accurately
have you
enough,
ever used one?
they can measure the
Have you ever
curvature.
used one, Joseph?
Not personally, no.
So would you say that your lack of experience is no match for someone who's actually used one?
Just because you use one doesn't mean you're using it correctly. And
How do you know?
I wouldn't think
How am I
she's
using
using
it
it correctly.
incorrectly? You don't
Because you're
even
using
know.
it
I doubt
over
you know the
too
first
short of
thing
a
about these, dude. You're
You
sitting
don't
here